table that we can use for this conversion. So if we go from degrees over to radians, what I do know is that to convert from radians to degrees, I've got to have some kind of relationship between pi and 180. Well, let's have a look at this here. If I'm going from degrees to radians, so I'm going from 180 to pi, what I'm going to do here is, if I'm going from degrees to radians, I'm going to be doing pi divided by 180. So my degrees to radians, the way I think about that here is, whatever I'm going towards, that would be my numerator. So I'm going towards radians. I know radians is in terms of pi, so it'll be pi on 180. If I'm going in the opposite direction, I'm going towards the degrees, so I turn that form around. So if I'm going from radians to degrees, well, how did I get 60 degrees here? Well, what I did here is I know pi equals 180, so therefore 180 divided by that pi value will give me that 60 degrees. Again, just think of the way I think it is, where I'm heading towards, that's what I want my numerator. I'm heading towards radians, pi will be my numerator. I'm heading towards degrees, degrees will be my numerator. So, if we look on here again, and let's plug in some of these values, and this is probably what we're going to look at a little bit later, is this here would be 90 degrees. If we're looking at it as a unit circle, we've got pi on 2. This down here is 1 pi, or half a pi, 1 whole pi. This here will be the 270 degrees, which is 1.5 pi, or 3 on 2. Reason why we're doing this here is what we're going to be looking at later on when it comes to the unit circle is using trigonometric ratios to help us identify exact patterns. So let's have a look at doing some examples right now in terms of converting degrees to radians and radians to degrees using this formula. Alright, so let's erase this part and put some examples up. So let's convert 135 degrees to radians. Let's try that. So 135 degrees to radians. So we know that this is what we're going to have. We're going to have 135 times pi on 180. What we can look at this in this essence here is, this can be rewritten as 135 on 180 times pi, because we want to answer this in terms of a radian. So if we look at this here, we're going to ask ourselves, well, what can I simplify into 135 and 180? So if we think about this here, let's get 4, so 45s, we get 3 over 4 pi. So let's just quickly check. 135, yeah, 45 works. So if I divide 45 into both of them, I get 3/4. So therefore, converting 135 degrees to radians is a matter of just using this formula. So 135 times pi over 180, 135 divided by 180 times pi gives me 3 on 4 pi. Oppositely, if we go the opposite way and went, let's now convert 7 pi on 9. So we convert 7 pi on 9. This here is what we're doing we want to go to degrees. So we would do 7 pi on 9 times 180. We know that pi is equal to 180 already. So this here could be 180 times 180, so it cancels out. So we get 7 on 9 times 180 over 1. And then we continue this through, and we get, if we look at this here, we would get 180 over 9 times 7. That gives me 20 times 7, which is 140 degrees. So if I'm converting from radians into degrees, I can use this calculation. 7 pi on, over top of pi. What essentially happens here is these two will cancel out. Okay? And now I've got 7 times 9, and these two will multiply with each other. So I cross multiply, I get 9 times 180 divided by, multiplied by 7 over 1, which is 7 over 9 times 180. These two then multiply out. So 180 divided by 9 times by 7 gives you 140 degrees. You could put it onto your graphics calculator as well and get that same answer, but this is how we do it without a graphics calculator. And we've looked at what a radian is. We've seen how we can convert degrees to radians, radians to degrees. Our next one we're going to look at is arc length and area. See you then.